Welcome to the third module of CPMAI, where we focus on the best practices and methodologies for implementing AI successfully. In this session, you will learn why so many AI projects fail, how to avoid common pitfalls, and how to adopt the right approaches, from development strategies to data-centric planning, to ensure your AI initiatives bring value to your organization. Despite growing interest and investment, up to 85% of AI and machine learning projects fail to deliver expected business results. Interestingly, the problem isn't usually with the technology or the talent. The main issue lies in the lack of adherence to best practices, such as clear problem definition, alignment with business goals, and realistic planning. That's why this module is so important. AI isn't like traditional software. Instead of deterministic logic, AI is probabilistic. It learns from data and evolves over time. Many failures happen when organizations treat AI as if it were like coding a standard app. Another reason for failure is unjustified ROI. AI projects require time, money, and resources. Without a clear business case and measurable outcomes, success is unlikely. Walmart once implemented shelf-scanning robots to automate inventory management. However, the robots didn't meet expectations and were replaced by human workers. This shows that even large companies can miscalculate ROI. It highlights the importance of aligning technology with operational realities. A major reason AI fails is because of poor understanding of data needs. You must know how much data is required, the right data types, and where the data will come from. Not having clarity here can result in under-trained models or overwhelming amounts of irrelevant data. Garbage in, garbage out applies heavily to AI. Poor quality data leads to poor model performance. You must ensure data is relevant, complete, and clean. Also, determine if you need to enhance or augment the data and whether your tech stack supports this process. Facebook once shut down an AI experiment after two bots started communicating in a language they invented themselves. While it wasn't dangerous, it was unpredictable. The key lesson here is the importance of monitoring AI behavior and not leaving systems unchecked. AI models often perform well in controlled environments but fail when deployed in the real world. A well-known example is an AI model that succeeded in Stanford Hospital but failed in a different hospital due to differing imaging protocols. Unlike humans, AI doesn't adapt easily to data drift. The solution is to ensure the models account for real-world variability and implement continuous model validation, monitoring, and iteration. AI projects are never truly done. Data changes, user behavior evolves, and real-world variables shift. Many projects fail because they don't allocate resources for ongoing monitoring and retraining. You need a plan for continuous improvement and versioning. Microsoft's Tay chatbot learned from Twitter and started mimicking toxic behavior. This example shows that AI exposed to biased or malicious data can produce dangerous results. Human oversight and data filtering are essential in all AI systems. Vendors often make bold promises about AI solutions, but many of them overpromise and underdeliver. Choosing tools based solely on vendor popularity can lead to mismatches with your actual needs. Always do your own research, ask tough questions, and make sure the solution aligns with your project's goals, not just market trends. Since the 1950s, people have overestimated what AI can do. This creates a cycle of hype followed by disappointment. Often, the real issue is poor problem definition and unrealistic scope. Instead of trying to solve everything at once, set clear, manageable goals and iterate. Learning from small wins leads to long-term success. The uncanny valley is a phenomenon where AI or robots that appear too human-like create discomfort. It also applies in data. When personalization feels invasive, people lose trust. A good example is Japan's NA Hotel, where the all-robot staff created more problems than solutions. The lesson: balance innovation with practicality and human expectations. AI thrives in an iterative environment. Iterative development means building in small steps, testing often, learning quickly, and improving continuously. This method helps you deliver early value, respond to feedback, and adapt to changing data. It's the opposite of the rigid, build once and launch approach. The waterfall model is a traditional, step-by-step approach with fixed phases. It works well when the scope is clear and unchanging, such as government or regulatory projects. However, it doesn't suit AI projects, which require flexibility and adaptation. The long timelines, often over a year, don't match the fast-changing nature of data. Lean methodology focuses on minimizing waste and maximizing value. It originated from Toyota's production system. The 5 key principles are: 1. Identify what customers value. 2. Map out the value stream. 3. Improve workflows. 4. Let customer needs pull processes forward. And 5. Continuously improve. In AI, Lean helps keep projects focused and efficient. Agile promotes collaboration, flexibility, and rapid delivery. Instead of following a fixed plan, Agile embraces change and encourages frequent releases. This makes it a great fit for AI, where requirements often evolve. Key Agile principles include prioritizing people, delivering working solutions often, and responding quickly to feedback. Data projects are different from software projects. You're not just delivering a feature, you're delivering insights. To make Agile work for data, you need time-boxed iterations, clear tasks, and structured demos. Be aware of challenges too. Estimating scope is hard due to data unpredictability, and meetings can take time away from analysis. Real companies show how Agile helps in practice. Netflix uses Agile to improve content recommendations. Panera Bread improved efficiency in digital orders. Fitbit used Agile teams to launch 4 products and ship 2 million devices in 1 year. These examples prove that Agile enables speed, responsiveness, and innovation, even in data-heavy environments. AI teams need role adjustments. Product owners should understand data deeply. Scrum Masters should support data exploration, not just sprints. The development team includes data scientists, analysts, and engineers, not just coders. Stakeholders must include people who will use the insights generated. The CPMAI methodology is built specifically for AI and data projects. It's rooted in CRISP-DM and consists of 6 phases: business understanding, data preparation, modeling, evaluation, and deployment. CPMAI promotes an iterative, data-centric approach that aligns with modern project realities. To succeed in AI project management, start learning CPMAI through Cognilytica's training. Join the global professional community through PMI and stay informed on evolving AI practices. CPMAI gives you the structure and flexibility to make AI work in the real world. Thank you for your attention. See you in the next chapter.